Hello, my name is Steve Matthews. I'm a Cisco's Industrial Solutions Architect based out of EMEA. In this video, I'm going to show how Cisco CyberVision and ISA 3000 Next Generation Firewall, both products designed for the operational domain, can mitigate and detect attacks that come from malicious users. So if you look at the agenda, first of all, I want to briefly describe Cisco Foundational Operational Security. I'm going to look at how easy it is to compromise a vulnerable host. And then I'm going to show how we can detect that kind of attack using Cisco CyberVision, which is a deep packet inspection tool, which can be passively deployed in the operational domain. And then in the fourth stage, I'm going to show actually how the ISA 3000 next generation firewall can also detect that kind of attack and actually block it reaching a vulnerable potential workstation in your operational domain. We believe the foundational security is key to making sure that your assets are secure. There are many customers that have no real degree of security today. And at the very least, we consider that what this video will show you is the kind of tools that are available that allows you to lock your domain down with segmentation, but also block malicious attacks, especially complex signature-based attacks using the Snort engine. There are two key elements that I want to show you today in foundation security. One is CyberVision, and the second is the ISA 3000. The third element is SecureX, but will not be covered in this video. In the first part of this demonstration, I'm going to show just how easy it is to compromise a workstation that is not being patched and is exposed to external attacking influences. I will show it from the perspective of somebody that has compromised a workstation that could be in the enterprise zone or actually could be in the operational zone. I'm going to use some well-known techniques against Windows operating systems, specifically something called Eternal Blue, which is a well-known SMB vulnerability. We will attack the host within that operational domain that's actually acting as a programming workstation using Unity Pro Snyder, although it could clearly be any kind of workstation. I just happen to have that in my lab, and we'll show what kind of compromises that exposes within your domain and how easy it is to really gather information. In this video, I wanted to show you how a relatively well-known tool, which is called Metasploit, can be used to exploit vulnerabilities within Windows operating systems. Clearly, Windows is widely used in all parts of manufacturing, and in this case, I wanted to show you relatively how simple it is for a completely unskilled operative to really take advantage of your machine, really, and take control of it. So I'll start by launching Metasploit, which is an incredibly very full-featured exploitation tool that's used by both white hats and black hats, as you know, in penetration testing, but also in by the bad guys, effectively. This is a very well-developed tool that continues to be added to. There's a lot, as you can see, there's a lot of exploits, a lot of payloads, and we'll talk a bit about that when I show you kind of the demo. And here, so the assumption is that I've broken into your operational domain and I want to take control of one of your important workstations that's used in manufacturing of some type. So Nmap is probably used by many people. In this case, I'm going to use it with a very specific script that comes with Metasploit that allows you to see whether some well-known CVE vulnerabilities exist within the machine that you're trying to effectively attack. So here I'm looking for some Microsoft exploits that are well known. They're called Eternal Blue, Eternal Romance. There's a whole Eternal family that's very synonymous with breaking into SMB, which is really that's probably the most vulnerable in Windows machines today, I think. So this will give me an indication if the machine is vulnerable to any kind of Eternal Blue attack. I've already gained access, right, effectively, so I'm kind of in the operational domain, as it were. And this is the address of the machine, so let's see what it comes back with. So you can see it very quickly started the scan, and it showed me which ports were open, via 445 and 139 being really important ones to attack effectively, NetBIOS and General Microsoft. But underneath here, because I ran this very specific script, you can see that it's absolutely vulnerable to a number of vulnerabilities around Eternal Blue effectively. So what I'm now going to do is, now that I know that that exploit exists, effectively I'm going to set up to use an exploit against it so I can gain access and download some software that gives me access completely to the machine. So what I need to do is really search the database of Metasploit for Eternal Blue and see what it comes back with. So there's a number of matching modules that I can use against machines within this range, as you can see. So I'm actually going to use the second one here, which will allow me to gain access and create a remote connection from the Windows machine back to my host. Once I've done that, I'm going to use a payload, a MetaInterpreter payload, which allows me to exploit many, many things within that machine, including screen sharing, effectively. So let me set up for that. I need to set up the actual address of the host that I'm going to attack. I need to, in this particular case, I need to set up my local host that the reverse connection will be made to. And now I need to set the payload, and the payload is the malicious code that can give you access to many particular features. In this case, I'm going to set the payload to a reverse TCP. So I've now set the payload. If I look at options for this particular exploit, there's many other things you can add. You can see you can add SMB, username and password, for example. It's definitely worth investigating tools like this if you've never seen them, because most people don't realize that the degree of availability and complexity in these tools to allow nefarious activity. So now I'm kind of set up. There was only a few things I need to set. I'm now set up to actually run the exploit. In the first case, you can already see that it does a scanner check to see is this vulnerable again. So yes, it's a vulnerable host. It's now corrupting some space within, I guess, the SMB buffer space to allow it to install its own little bit of code, and then it will enable the MetaInterpreter so I could basically get a pipe into the system to be able to exploit various things. And I'll give you an indication in a second of the kind of things that you can actually get to, and it's quite an extensive list that this kind of exploit will give. So that process is now complete. It took a few seconds to complete. And you can see the second one when it says win, it tried a few different alternatives. As you can see, it failed the first time, but ultimately on the second pass, this banner at the bottom indicates that I'm actually in the machine with a reverse connection, and I've now got effectively full control of that machine. The MetaInterpreter allows you to issue commands directly from here into the machine for a variety of features. One of the things I can do immediately is get a shell. So I'm now in a DOS shell directly in the machine, and you can see all the files that are listed. And so you can actually then modify, change, etc. If I go back to the MetaInterpreter, there's some, if I do help, you'll see that I can now scroll back to a list of commands that I've got available, which is it's quite an extensive list, right, of things that I can do. These core commands relate to the actual application itself that we're using in the MetaInterpreter. But here, all these commands underneath all can be issued directly from the CLI. And you can see I can edit files, I can make directories, I can remove files. I can actually look at the networking elements. I can change privileges. I can do an awful lot of things that could be, first of all, hidden and damaging. So you can see here that I can actually do key scans, key dumps, screen share and screenshot, and all these things, function without the operator or anybody on the machine actually knowing, unless I do some things that would be obvious, like launch an application. A couple of the interesting commands would be, if I do PS, I will get a list of all the processes that are running on the machine. I can do screenshots, screen share, etc., as I said. So one that is probably interesting is if I do hash dump, this will give me a list of all the usernames and passwords that are available on that machine. And in this case, I can crack those passwords relatively easy. I'm going to show you how that looks with a relatively simple password cracking tool. And then those passwords with the username can be used for activities such as remote access, assuming those users are allowed to connect. Clearly, I'm able to attack and do pretty much anything I want in this machine. So what I want to show you in follow-ups is how we get visibility assuming you've got a tool like Cybervision of this attack that's in progress at the moment, and then ultimately how you can stop that attack using a next generation firewall, which has knowledge of the same signatures that we use to connect from this attacking machine. I'm just going to show you briefly how relatively simple it is, maybe time consuming, but how relatively simple it is to crack clear text passwords. And what I've actually done is I've arranged the passwords that are encrypted from that Windows machine into a file. And I've also got a dictionary file. So Rocky.test is basically a clear text dictionary of kind of very standard passwords. And this is typically what you see. There are varieties of these kind of password files. So what I'm actually going to do is I'm going to run a program called Hashcat. And there are several other versions of things like this, but Hashcat allows me to run against the hash file, and I know it's a Windows hash, so therefore I'm going to pick the right algorithm, and M1000 is NTLM effectively. I'm going to run that against the hashes that I have, and I run that against the dictionary, and I kind of hope that the passwords might be in there effectively. Because this is a virtual machine, I need to make sure there's enough compute power, so I have to force it, and off we go. So within about 3 or 4 seconds, there we go. If you look in the center of the screen, it's actually ran across all those passwords, and this section here are the cracks. Effectively, the words, as you can see on the right hand side, are the passwords effectively, and they're against those particular users. So if we have a look at the hashes file itself, if you compare this 82, it's actually this particular user. So shift supervisor's password is exclamation mark password 4321, and clearly CNC operator, which ends 3302, is Apple's. And once you've got those, once you've got the username and password, of course, you can then potentially use those credentials in any kind of dial-in scenario where you kind of dial into the network to gain remote access. I hope that was a useful indication of how relatively simple it is to crack simple passwords. So in this next section, we're going to look at how Cybervision can detect the kind of attack that you just saw. So the process is kind of the same. You know, attacker will come down from a compromised workstation. It will attack a workstation with SMB vulnerabilities, and Cybervision will detect that both at an IDS level, but also at a baseline change level. Without Cybervision, you would not be aware this attack was happening, and your overall IT security teams would have no visibility of this. So let's move over to Cybervision and take a look at its ability to be able to recognize the kind of attack that I just did and see what kind of messaging we get within the platform. In this case, the platform is already has the assets that I'm going to attack, and in fact, it's the top device here, and the circles, by the way, are the vulnerabilities. And you know, this isn't a full Cybervision session, but it's going to just show you how effective it is in seeing signature-based attacks and things like port scans. So I'm going to go across and we'll look at the events first of all, which is where things will show up, and then we can drill into them. You can see there's no critical events. We've got some anomalies, but this is mostly baselines during the learning process, because I've got a preset set up that's a baseline for that particular 3 devices, and anything it sees different from that will be reported as a change effectively. So we should see our attacker in there as change, all its new flows as change, etc., as well as signature-based attacks showing effectively critical events. So let's just toggle back to Metasploit. So first of all, if I run the Nmap sweep effectively, which was the thing that we did first, we should hopefully, when we go back and look at the event, see this as effectively a kind of a port scan attack, because that's really what it is. We're trying lots of ports on that particular device, and then I think I'm already set up for attacking the device using Eternal Blue. So let me kind of run the exploit on the host, which is the one in that triangle of devices in the preset. And hopefully we should see a number of different things. We should see the DOS attack, but we should also see the signature-based attack around Eternal Blue, effectively, and MS 1710. show up as received by, in this case, we have an IC3000 sensor that's collecting traffic from that network segment in a passive fashion. So let me toggle back to the console, and you can see dynamically in the background, actually critical events have appeared during that attack process. So we've got a combination of signature-based attacks and also a security event. So you can see here there was a port scan detected on a component. That was in fact the Nmap sweep that I did. And you'll see if I drill down into the event, you can see this was the component which has got a strange name in SMB, which was attacking this particular device. And it shows you the time, the IP addresses. If we go backwards into the event log, now all these events would go in syslog and will be passed up to the SEIM. If we go back, because the attack is run its course and we've got some more data now effectively, you will see signature-based detection for a privilege gain, which is effectively what you see for an internal blue MS 1710 attack. And these messages will show effectively that it was an SMB RCE attempt on SMB, and it shows you the host attempted administered privilege gain. So these should be important warnings that in fact you have been under attack by some malicious hacker that's really trying to break into one of the workstations. So let's quickly toggle across to the baselining, which is where also we'll have information about different flows that happen during that. Within the baselining for that particular cell, if you recall before, we had the 3 devices. Now we have a new asset, and this red line on the outside shows something new appeared, as well as actually a whole load of flow information from that device. If we click on the link for the flows, you can see there's been 1,200 flows in that period from that particular device. And clearly we could acknowledge or report these. If we report that activity for this particular device, you can report the anomaly as malicious event, say. And effectively that will also appear now in the event log, and we'll go to the SOC. So you immediately got the OT department linked to the IT kind of SOC SEIM with an event. So if we go back to the dashboard for events now it's completed. You can see the port scan. There's obviously a baseline change, and this is the one I declared a second ago. So this is where I've said this activity was malicious and should never occurred. So that's a window into how Cybervision as a passive platform can give you information on malicious activity, both port scans and signature-based IDS attacks. In this final part, we're going to look at how we can use Firepower and ISA3000 as next generation firewall system to effectively block and drop the traffic based upon the track that you've seen from MS17. It uses the same snort rule set, but the firewall can actually drop the offending traffic and it will not reach the operational workstation that's vulnerable to the attack. So you will see us attempt the attack again, and the firewall will receive that, and you will see in its event log effectively that it's seen it and it's dropped the traffic. We'll now move the attacker to outside a Cisco next generation firewall and ISA3000, which is being managed by Firepower Management Center. As the configuration is set at the moment, it has kind of medium level security, but even medium level security should be able to block a very specific attack like this, which is well signatured. And so let us attempt the same attack, but this time coming through the ISA3000, trying to get to that particular host again. It's already configured with the right parameters, so let's just run the same attack again. And because it's medium security, SMB is allowed through, but the system will discover that this is actually an attack vector, and it will not proceed past this point. And within Firepower, we will see that we'll actually record this as an attack, and we'll have dropped the session. So let's take a quick look at how Firepower Management Center and the firewall are configured to block this attack. So without going into all the details, let's start by very quickly looking at the kind of policy and how Snort IDS is driven out of that. So if in FMC I go and take a look at policies, and initially we look at the access control policy, the access control policy is going to decide, which traffic gets through effectively, but as part of it, you tie intrusion detection rules to the policy itself. So let's have a quick look at this one, which is actually the rule set that we're using for accessing into the operational domain. And there's a couple of things to point out. Firstly, I can put a very specific intrusion detection policy on the rule set. And here, if I mouse over this particular rule, you'll see there's an IDS policy set, as well as actually a file policy set. If I don't set the values there, I actually end up with a default action. And you can see here, I've actually configured one to make it visible so you can see which rules are available. But ultimately here, if in this pull down, you've got a range of policies that are available in this rule set that allow you everything from basic access control through to intrusion prevention. And I've selected balanced security and connectivity. In my case, what I was probably classing as medium level security, where it will drop really serious attacks. So you have a lot of flexibility in the default ones, but ultimately you can configure these to your own requirements. And so this user created policy is basically that balanced security policy, so that I can kind of show you the rule set. If we actually go and look at the default action, which in case is this kind of balanced security and connection policy that I've pulled out so that you can see the rules, you can actually see that this balanced security has 11,936 rules enabled, of which 500 generate events or messages, so will not drop traffic. However, 11,436 will generate events and actually drop the traffic. So let's take a look at what those drop-in rules are. If I scroll down this side of the screen, you can see you can do it against files, but there's obviously classes for things like Microsoft vulnerabilities. So here I'm doing an MS1710 attack. So if I scroll down here to MS1710, drop and generate events for MS1710, you can see there's 4 event rules that are with its snort ID. Expect one of these to be impacting that traffic. So if we now jump across to the analysis for intrusion detection events, which is where we'll see effectively the block, what you're going to see is this was the actual rule set that was triggered, and we were just looking at this 429944 in that MS1710, and this was the rule that was triggered that actually prevented malicious traffic from entering the system. And you can obviously see I've done this test a few times, of course. So if I scroll sideways, you'll see the same kind of information that you would see against the rule set, which is the exact same rule set that would be in CyberVision, though in this case we're obviously triggering it inside the firewall, and because it's a firewall, we can actually block that particular rule. So let's take a look at how Firepower can visualize the initial part of the attack, which was the Nmap suite. To allow this, we need to add a specific network analysis policy, which I'll walk you through now. So effectively, within the access policy that we created, if we drill into the actual policy, the access policy in use, there's a number of tabs at the top, and you'll see advanced. So if we look in advanced and slide down the options, you can see a network analysis intrusion policies. So what I've done is I've enhanced what we had before by adding a new network analysis policy called Nmap test. And this is the one that is going to detect the port scan and show it in the event log. So if we take a look at the policy, that particular policy in the policy list, which is called Nmap test, you'll actually see some changes that I've added to override what was there. So if we look in the policy layers, in my changes, it pops up this window of the behaviors of existing features, and you can see that pretty much everything's set to inherit, except at the bottom for port scan detection. I've enabled port scan detection, and I've actually then gone and tweaked some of the parameters. So what this does is it allows us to get that visualization in the event log of the actual port scan attempt. So now we will actually see an extra message that will pop up to show that our port scan attempt had been in place. So let's prove that point by going back to analysis and events. I've already ran the attack before, and you can see now we see a new event log message, which is a port scan message. So let's drill into that a little bit. I think you get the idea that effectively the same source and destination, we had a port scan detected. And actually, you can then go and view very specific details, which I didn't do for the other attack, just to show that you've got a lot more information available for everything that goes on. And you can see this event is generated when the preprocessor port scan detects network traffic that may constitute an attack. So that is how we add a policy to detect something like a port scan to make it equivalent to the two different types of attacks that you saw happening during the session. So that concludes the video for CyberVision ISA 3000, showing how they can protect operational domains from intrusion-based attacks. I've included some links to show Cisco.com related resources for industrial security. Please check them out if you need more information. Thank you.